Question 6c. The points CD lie on the line L2, so we've got C and D. Such that ABCD is a parallelogram. We know that this is the point of intersection. We'll call it P, which we found up here. So P is 2, 0, negative 1. AB, so we know AB from part A. We know the length AB is equal to the square root of 560. It's 3 times the length of CD, so CD is 3CD is equal to root 560. Find the coordinates of points C and D. Okay, there's 2 ways to do this. One way is a little bit like the shortest distance problem, and the other way uses the points C and D and the equation of the line, the direction vector of the line. So I'm going to do it the second way because that's kind of what we're used to a little bit. Okay, so we know that some point on L2, let's say it's D, is equal to D even, negative 1 plus 3 lambda, 5 minus 5 lambda, negative 2 plus lambda. And we know that P is in the middle. So we know that PD, or DP, depending on which way around you want to write it. I'm going to write it PD, DP actually. It's just a little bit easier. No, I'm going to write it PD. PD. So that is equal to negative 1 plus 3 lambda, 5 minus 5 lambda, negative 2 plus lambda, minus 2, 0, negative 1, which is going to give me negative 1 minus 2 is negative 3 plus 3 lambda, 5 minus 5 lambda, and negative 2 plus 1 is negative 1 plus lambda. Okay, so now I've got PD, and I know PD is half of CD, so PD, 2 lots of PD equals DC. So AB square root of 560 is equal to 6 lots of PD. Okay, so I can, now if I work out the length of PD, I can figure out lambda. Once I've got lambda, I can figure out D. It's going to come out as a quadratic equation, so I'm going to figure out 2 possible lambdas. One will give me D and one will give me C. Or that's what I'm hoping anyway. Kind of hoping. I also kind of know that's what's going to happen. So, root 560 equals 6 lots of the square root of PD, so negative 3 plus 3 lambda squared plus 5 minus 5 lambda squared plus -1 plus lambda squared. Okay, I'm going to square both sides, so that gives me 560 equals 36. Oops, not 360. 36 times -3 plus 3 lambda squared, so that would be 9 minus 18 lambda plus 9 lambda squared. 5 minus 5 lambda, so that would be plus 25 minus 50 lambda plus 25 lambda squared. -1 plus lambda squared, so that would be 1 minus 2 lambda plus lambda squared. So 560 equals 36 times like terms here, so we've got 9 plus 25 is 34 plus 1 is 35. I'll put that at the end. Plus 35. -18 minus 50, -68, -70, -70 lambda, 9 lambda squared plus 25 lambda squared is 34 lambda squared, plus lambda squared is 35 lambda squared. Okay, so I can see here this has got a common factor of 35, so I'm going to divide both sides by 35, which I know from before is going to give me 560 divided by 35 is 16 equals 36 times lambda squared minus 2 lambda plus 1. Divide both sides by 4, I guess, so 4 equals 9 lambda squared minus 18 lambda plus 9 minus 4 both sides, 0 equals 9 lambda squared minus 18 lambda plus 5. Factorise that, so multiplies to 5. 3 lambda minus 5, 3 lambda minus 1, multiplies to -15 minus 3 lambda, yep, so that works. Okay, and then solve that, so lambda equals 5/3 or 1/3. So that's given me my 2 lambdas, one for C and one for D. So put those back into my point PD equation, my equation for D, I guess. So one of them is, we'll just say D is equal to 1, lambda is 1/3, so it's -1 plus 1, which is 0. 5 minus 5 times 1/3. 5 minus 5/3, that's 15 minus 5 is 10/3. You can do that on a calculator, that's fine. -2 plus 1/3, so that is 5/3. -5/3, and C, that is just from my calculator, 4 -10/3, that's -10/3, and -1/3. And those are my 2 points, C and D. So how the marks were awarded here, you got 1 mark for finding this, doing one of these here. So that was a mark. You were given another mark for basically this bit here. So that was another mark there. Mark for factorising, and then the 2 A1s, 1 for each. So that's a really tough question, really tough. So good job those who attempted it. If you want to see the other method because you think you might prefer it, you are more than welcome to ask me about it. Yeah, it's basically the same. Okay.